right, and we're back to it. Can you believe that a week of school is already by? 1 week in the books, done. All right, and we're moving on to the start of our final lesson in Unit 1. Can you believe that? 1 week in. Woo! Quarter system, baby. All right, so we are talking about Lesson 6 in Unit 1, which is exponential functions and table of values. So you should hopefully have these notes out in front of you to begin today. All right, so once again, this is our fourth function. And so now we have had linear, absolute value, quadratic, and now exponential functions. All right, so you're going to see once again, we're looking at the same things. Can you identify an exponential function from a table? Can you identify the rate of change for that exponential function from a table? And then can you fill in those missing values or extend a table, all right, using your knowledge of rates of change in exponential functions. So this kind of concludes our unit by getting our fourth function involved, all right, and we'll see some key characteristics of this function. Just like all of our other lessons, all right, going to have a little opener here to get you thinking, seeing some patterns. All right, so let me read this to you. The table of value represents the number of bodaciously green bullfrogs after reentry by DOAL, Dole, the Department of Amphibian Lovers, baby. All right, so fill in the missing values of the table and answer those three questions. So as we've done every day before, go ahead and pause the video, fill out that table, answer those three questions, turn the video back on, and we'll see how you did. All right, so are you an amphibian lover, right? Are you a member of Dole, right? Okay, we'll see if that really exists someday. All right, so just like we've done with everything else, we want to look at, all right, how that X column, how the time is changing. So we're going up, all right, by 1 each year. So 1 year, 2 year, 3 year, 4 year, 5 years, 6 years, and then 7 years. Okay, so now once again, when we look at, all right, our first change in Y, all right, how did those frogs, all right, those bodaciously green bullfrogs multiply? So they went up by 26 the first year, all right. They went up by 52 the second year. So right now, right, okay, right now we have cut our list in half, right? So we know that linear and absolute values have a constant rate of change. 26 to 1 and 52 to 1 not equal. They're done. They're gone. See ya. All right, so now we're down to two choices. All right, quadratic and an exponential. All right, we'll talk about how to differentiate those two in just a moment. All right, when I go from year 2 to year 3, they increased by 104. All right, so now let's look at this pattern here, right? Okay, all right. What we see here is doubling, right? So 26, 52, 104, 208, right? We can see that it's doubling, all right? Okay, so our value is doubling. So now if I add that on, that's 416. And then it doubles the next year, so I get to 832. And it doubles the next year, and so I add that on to 832, and I get to 1664. And I double that, and I've added those together, we get 3328. All right, so we see this pattern in the numbers, right? It's a little different than the pattern of quadratics, and that's how we'll tell the difference between the two. All right, so this is, in fact, an exponential, all right, and we'll get to that Y in just a moment, all right? But here are some key characteristics. So once again, if you need to pause the video, all right, to write all this down, do so. All right, here we go. So the first key characteristic, it only increases or decreasing. There is no turning point. So this is like a linear function. All right, it increases or decreases differently than a linear function, but it only goes in one direction. All right. The rate of change increases or decreases by a multiplier or factor, whichever word you want to use. So like that would have been multiplying by 2 in our opener, which is a factor of 2. All right. It could go down by a factor of 2, which means it would go in half. So it would go like 50, 25, and so on. And then we get kind of a lazy L graph, right? All right. So where it's going up or it's going down. All right. So we kind of get that lazy graph like that. All right. Okay. So there you go. All right, so there are some key characteristics. All right, so let's look at an example here. So once again, when we think about what we have, right, okay, all right, we have 4 choices to start with, right? Linear, absolute value, quadratic, exponential. And we said one of the first things we want to do is scan our table and see if we see a turning point. So when I look at this table, I don't see a turning point, so I can't eliminate anything right now. So we want to get into rates of change and see if those rates of change will help us eliminate anything. So add 1. add 1, add 1, add 1. So we can see that left-hand column, right, our values of x are all going up by 1. So now we want to flip over to the right side. Let's see how those y's are changing. So my first change in y is up 2. All right, so now my next change in y is up 6. So my first two rates have changed. 2 to 1, 6 to 1, not equal. All right, so we do not have a constant rate of change. And what can I throw out right now? That's right, I can't hear you, but I know you said linear. See ya. All right, what else did you say? Absolute value. I know you did. It's gone. All right, so now, all right, we have two choices. We have a quadratic or we have an exponential. And once again, we're going to look at these changes, right? So if we look at that next change in y, 9 to 27 is plus 18. Now, here's what we said. If it's a quadratic, it's going to change by the same amount. So when I go from 2 to 6, I add 4. When I go from 6 to 18, I add 12. That is definitely not the same amount. All right, that second difference is not equal. It should have been plus 4, plus 4, plus 4. It is not. So guess what we get to get rid of now? That's right. We're down to 1, the exponential. All right, so those are gone. Now here's why it's nice, because if it's exponential, I know it's either multiplying by something or dividing by something. Now, since my rates of change are getting bigger, 2, 6, 18, I'm looking for a multiplier. So what do you multiply 2 by to get to 6? You multiply by 3. What do you multiply 6 by to get to 18? You multiply by 3. All right, so to get my next rate of change, I have to multiply 18 by 3, and that gives me 54. So then 27 plus 54 is 81. To get my next rate of change, I got to multiply 54 by 3, and that gives me 162. Add that to 81, 243. Now I have to multiply 162 by 3, give me 486. Add that to 243, now I'm up to 729. Multiply 486 by 3, that gives me 1458. Add those two things together, right? Add those two things together, 2187. Multiply that by 3, 4374. Add that to 2187, and we get to 6561. All right, so there you go. There's an example of an exponential function. All right, so we're looking for that multiplier or divider. Okay, so now, how would we describe our rate of change? We were going to say it's increasing by a factor of 3. You can say it's increasing by a multiplier of 3. All right, but we want to say increasing because it's going up, and we want to describe what you're multiplying by. So increasing by a multiplier of 3, increasing by a factor of 3. All right, and then our function would be, that's right, we had that down earlier before we even finished the table. We knew it had to be an exponential. All right, so here's what we're going to do. We're going to actually skip example 2. And we're going to skip to example 3 here because I want you to see something a little bit different. So just go ahead and skip to example 3. We'll do example 2 in class tomorrow, all right, when we come back as a whole group. So here we go. All right, so once again, what are our 4 choices, right? Linear, absolute value, quadratic, exponential. We're going to scan our table, right? Going to look up and down. Do I see a turning point? I don't see a turning point. So nothing we can throw out right now. So let's look at our change of x and our change of y's. So when I look at that left-hand column, once again, you can see that my first change of x is plus 1. My second change of x is plus 1. My third is plus 1. My fourth is plus 1. Plus 1 again, plus 1 again. All right, so all my x's are going up by 1. So now let's jump over to the right side and let's look at those change in y's and see what's happening here. So when I go from 128 to 64, I go down 64. All right. When I go from 64 to 32, I go down 32. So we're going to hit the pause button. Not literally. Don't hit the pause button. Listen to my redneck voice. All right. Listen to me a little bit longer. All right, before you give up on it. All right. So we look at those first two changes, right? Negative 64 to 1, negative 32 to 1, not equal, not a constant rate of change. All right. That means we can throw that linear guy away. See ya. Absolute value. You out of here. We're down to 2. It's either quadratic or an exponential. So let's look at our last change of y that we can gather here in our table, which is down 16. All right, so now we have to decide, is it quadratic, is it exponential? So let's look at how those numbers are changing. So when I go from negative 64 to negative 32, I subtract 32. When I go from negative 32 to negative 16, I subtract 16. So that is not the same. They're not changing in the same way. So that means that it cannot be quadratic. So we get to kick that guy to the curb. See ya. You're out of here. We know it's an exponential. All right. And then once again, if it's an exponential, now we're looking for a multiplier or divider. Now this is why I wanted to skip example 2 and go to example 3, because our numbers are going down. Negative 64, negative 32, negative 16. And if our numbers are going down, that means we have a divider instead of a multiplier. All right, so now what I'm looking for is like, what do I divide negative 64 by to get to negative 32? All right, and I divide by 2. When I divide 32 by 2, I get to negative 16. So there's our pattern. And some of you may have seen that before I did the work for the quadratic. And if you see that pattern right away, you can jump right to it and say, I'm dividing by 2 and go. No worries. But I wanted you to have that process that if it's not obvious, if it's not evident, you can just systematically go through and eliminate your choices till you get down to the proper one. So now to find my next rate of change, I have to divide negative 16 by 2, and that's negative 8. And then 16 minus 8 is 8. All right, to get my next rate of change, I need to divide negative 8 by 2. That's negative 4. 8 minus 4 is 4. All right, negative 4 divided by 2 is negative 2, and then 4 minus 2 is 2. Now, you may have seen this pattern in the table as well. So sometimes with an exponential, it will show up in the table. So 128, 64, 32, 16, 8, right? You can see that everything's dividing by 2. It's not always that obvious, which is why you want to go ahead and write out your rates of change, all right, and examine those, just in case it's not, all right, just real clear in the table itself. So once again, how do we describe our rate of change? Well, the first thing is it's decreasing, right? It's going down. And so it's decreasing by a factor of 2. You could say the rate of change is being divided by 2 if you want. All right. And then it means it is an exponential function. All right. So short, sweet lesson, all right, wraps up, all right, this guy for you. So tomorrow we'll pick up with this lesson in class. Have a great Wednesday night. I will see you tomorrow. All right. Go watch some Netflix, some Hulu. All right. Have some fun. See ya.